systems, site management with the help of water management, etc., and all. Greener form of transportation, bicycle, as far as the project is concerned, green building project is concerned, bicycle tracks, etc., electric vehicles, etc., and all. I just told you about the site waste management, recycling, and proper waste disposing. It is not only recycling the waste, recycling the construction material also, like quarry, concrete and all. It can be recycled and then it can be used once again. So that way the energy consumption is getting reduced, the carbon emission is getting reduced. And also finally, proper planning by means of proper stormwater management, as also the site water conservation. And that is required as far as the green building concept is concerned. We know that earlier we were having the earthen structures and all about. Little bit we will be going into little history. Rammed earth and other similar structures are perhaps the greenest material, The soil is rammed and then we are making walls with the help of that rammed earth or something like that. That is called the adobe. And a greater replacement of the traditional concrete masonry. It is composed of clay, dirt, gravel, and lime. That much only. Now also we are having a lot of buildings which are coming up with the help of adobe, that is the rammed earth. They offer durability and insulation. We know the earth, it will offer the durability and insulation to buildings. Rammed earth can be used for walls and flooring and act as thermal storage. That means it will absorb the heat. That's what is given. Rammed earth is also a highly energy efficient building material due to its high thermal mass. It will absorb the heat and store heat, reducing the need of heating and cooling systems. So that can be a prime material as far as a green building concept is concerned. Then we are having bamboo. We know that bamboo is a material which can replace the steel also. It is lightweight. We know the weight of the steel is nearly 7850 kg per cubic meter. So here we are having the bamboo, which is very light in weight, flexible and much cheaper. That's right. And it's having a better tensile and compressive strength with respect to concrete also, and also with respect to the steel. The split tensile strength is nearly 3 to 4 times that of the concrete. And the tensile strength with respect to steel is almost same. The compressive strength is nearly some 30 to 40 MPa or something like that. Bamboo can be used for ceilings. It can be used for construction, flooring, walls, partition, and structural components like beams and trusses, because it is having a better tensile strength. It is easy to assemble and it's abundantly available in India. Engineered bamboo. What does it mean? Engineered bamboo. Bamboo which is available naturally and man-made product. That's what, which can be used as the beam, which can be used as the joist, which can be used as the column. That's what engineered bamboo products are used for making medium to high-rise building. Mistaken for such a traditional material, its modern counterpart is still relatively untapped market. We are not using, that is an untapped market. Western countries and all are using bamboo. That means engineered bamboo, man-made bamboo, which can be made as a structural component as far as the building is concerned. Engineered wood, not the natural wood, engineered wood. That means the way we make the wood. We are having the furnitures, which are made up of fiber boards. That is engineered wood. 2 types of wood are well liked by green builders, engineered wood and wood certified by various authorities. Certified by SSL or something like that. So engineered wood uses the wood scraps. That means it will be using the scraps of the wood and small trees to produce framing stronger than the natural logs. What they will do? They will be bringing the wood scraps, etc., and then they will compress it with the help of some resins or something like that in the machine, and that can be used as a better material. It helps the builder use less wood for structure. That is a waste from the wood or something like that. It is a scrap. So it is just brought to the industry, and then it is mixed with some resin, and then it is compressed to make some fiber boards, to make some other material as far as the building is concerned. So it will consume less wood per structure. We are having we are having the slate and stone. We were having earlier stone buildings and all. Is it not? Nowadays, we are not having that one because we consider the stone is very heavy or something like that. The stone construction is an excellent green choice, but not fruitful on the economic side due to high labor and material cost. The price are relative to the availability of them. If stone is available, that's what it is. If it is available nearly, that's what earlier we mentioned, that it is locally available material. Why not to use stone? It is known for its durability, long lasting, and these structures last for decades. We are having some structures which are built of stone or something like that, which are there for so many years and all. So which is available nearby, we can use that one. The use of slate is common in roofing system. Even in India, many of the areas in the northern part or in the western part, if we go, we can see some construction which is having the roofing which is made up of slates or something like that. Slates, wherever it is available, we can use. So stone and slate. Then grasscrete and hempcrete. It's something like a method of laying concrete with spaces for grass to grow. It will be like this. So we are laying the concrete with grass to grow. The main advantage is that it will allow the water to seep in, and then less quantity of concrete is required. So overall concrete usage can get reduced and improve stormwater absorption. And finally, it can be drained somewhere and it can be stored. That's what it is. It is not just like it is observing. No, it can be drained out and then it can be stored somewhere, which can be reused again. Hempcrete is a material made of woody fibers of the hemp plant with concrete. Again, not only with the grass, we can make it with hemp or something like that from wooden fibers, so that stormwater filtration and drainage can happen, and then it can be collected and it can be reused somewhere. So that's the green building concept. Structurally insulated panels. All of you might have heard of this cavity walls and all, is it not? Why we are having the cavity walls? Cavity walls will be having air inside or vacuum inside two panels, which will not allow the air to pass through. So it is an insulated material. Yeah, it will maintain the heat, or it will preserve the heat in the building. There is no need of any extra ACs or something like required, because it will preserve the heat as far as the season is concerned. So we are having the structural insulated panels typically made in factories. The panel consists of foam insulation sandwiched between two sheets of some cardboard or something like that. And this foam will be having the pores, and these pores will be having air inside. We know that when air is there inside, it will not allow the heat and sound to pass through. So acoustics can be better, and even it can give a better thermal insulation. They have extraordinary air sealing and insulation properties. Some drawbacks includes an expensive installation process. They are low fire resistant. But research is going on now to see the drawbacks in order to have in order to make this material a little bit good as far as the durability is concerned. So we can use some structurally insulated panels also. We're having natural clay plaster. Usually we'll be going for the cement plaster, lime plaster, etc. But a green alternative to common gypsum plaster, when paired with good workmanship, can provide a beautiful earthy finish to interiors. Many of the buildings we can see, they'll be having some clay plaster or something like that. Clay, as said, soil is a siliceous material. Is it not? We have to mix it with a little bit cementitious material, so that proper binding can happen due to the clay, and proper strength we will be able to get due to the cementitious material. So it is not toxic, biodegradable, dust resistant, durable, etc. It absorbs the moisture, keeping humidity at bay and regulating the room temperature. So that can be a green building concept as far as the material is concerned. So what can be the principles of the green building? I just mentioned in different 5 points. We already discussed that one. Structural design efficiency. How we are going to design a building. Design a building in such a way that the life cycle cost can get minimum. The maintenance cost can get minimum. We can have some daylight temperature inside the building. Orientation is made in such a way that there is no need of extra lights or something like that in that particular building. There is no need of extra air conditioners in that particular building, so that we can design the windows like that. The number 2 is energy efficiency. So when we have a building with the help of some energy conservation materials or something like that, we can preserve some coolness inside the building, so that we can have some light, natural light inside the building. So the embodied energy as well as the maintenance which is required as far as the electrical consumption is concerned is getting reduced. Water efficiency again, how to use the water, how to reuse the water. Again, by means of some small treatment or something like that, we can reuse the water. There is no need of wastaging that particular water. Material efficiency, we just told, and waste and toxic reduction as far as the waste management is concerned. Structural design efficiency is the concept of sustainable building and has larger impact on cost and performance. Just now we discussed that one, and ensures appropriate ventilation, natural ventilation, moisture control, and avoid the use of materials with high voltage organic compound, high VOC, like paints and all. Okay, we are using high VOC paints and all. We are using some resins and all. That has to be limited as far as the usage is concerned. Structural design, we have to design in such a way that energy efficiency. The layout of the construction can be strategized so that natural light pours, and shading the roof with trees. Again, we are having at rooftop, we are having the plantation and all, grass and all. That way, it will not allow the heat to pass through. That way, insulation is possible. So shading the roof with trees offers an eco-friendly alternative to air conditioning. As far as water efficiency, the minimize the water consumption, use the water which has been collected, use, purify, treating the water, and reuse that one. Material efficiency, material should be used that can be recycled and generate surplus amount of energy. Nowadays we are having material which is called as carbon negative construction materials. That means it's absorb the carbon from the atmosphere. Like research is going on, like iron powder or ferroc or something like that. Research is going on now, which is considered to be a carbon negative construction material, which will absorb the carbon from the atmosphere. That way, you see, carbon emission is zero, we can tell. An example of this are solar power panels. As far as the energy is concerned, we can use the solar power panels. Not only they provide lightning, but also they use suitable energy source for power and something like that. Okay. Then waste and toxic reductions, again, proper waste management, reuse the resources as far as the building waste is concerned, and what may be the waste to us may have another benefit to something else. The example is some admixtures. We are thinking, we see the thermal power plant waste, it is used in the construction industry. Iron and steel waste, which is considered, which is called as the GGBS, is used in the construction industry. rises cash. Yeah, again, from the agriculture, it is used in the construction industry. So wherever the waste, yeah, it may be a waste for somebody, but it can be reused again as far as the construction is concerned. Now, this is directly from the website. I'll just simply go through that one. Eligibility, as far as the green building rating is concerned, all operational buildings built up area more than 2,500 square meter are eligible for certification under GRIHA, that is green rating for integrated habitat assessment for existing buildings. This is for the existing buildings. How to make the existing buildings a platinum rated one or gold rated one or something like that. Okay. The typology of buildings include, it can be offices, retail spaces, institutional buildings, education buildings, hotels, hospitals, then healthcare facilities, residences, and multifamily high-rise buildings and all. Now, a green building rating system is an evaluation tool. How the rating is done, based on what criteria the rating is done, is an evaluation tool that measures the environmental performance of a building throughout its life cycle, throughout the entire life of the building, how the performance of the building. We will be just, measuring the environmental performance of the building. That means how much energy is consumed, embodied energy, how much it is there, how much carbon is getting emitted. All those things will be measured. It comprises of a set of criteria covering various parameters. Just now we mentioned that related to design. It can be with respect to construction and operation of the green building life cycle cost. Each criteria has pre-assigned points. Each criteria will be having its own points and sets performance benchmark and goals that are largely quantifiable. A project is awarded points once it fulfills the rating criteria. The points are added up and the final rating of the project. This is how the rating system works. So before going for the rating, we must go for the feasibility check. The owner or project team is responsible for the feasibility check. They should check if the project is eligible for GRIHA. Okay, they must do some homework or something like that for existing building with the help of online feasibility check. It is available. The successful completion of the feasibility check enables the project to register under the GRIHA. Then registration is followed by an orientation workshop conducted by GRIHA Council. The intent of the workshop is to provide detailed information of the existing rating available in all the criteria. And then we have to submit the documents. The project proponent must submit the documents for all criteria as far as the operation, as far as the construction, as far as the material, as far as the energy conservation, all those things. They have to submit the documents. And preliminary evaluation, that means a recce will be done by the GRIHA Council as professionals. They will first review the compliance of the project with the mandatory criteria, and they will reject. They can reject also in the event of non-compliance of such criteria. And site visit will be done. A due diligence site visit will be done by GRIHA Council to verify the submitted documents, and due diligence report shall be submitted within 7 to 10 days work days of the site visit. And the final evaluation will be done by GRIHA Council in response to preliminary evaluation and due diligence report. On the basis of the evaluation, the GRIHA Council prepares final scorecard within 20 to 25 days. This is how the rating of an existing building can be done. It is given clearly in the website. What should be the area of that one? What are all the criteria? Yeah, that is important. This is the score. Okay. Usually they'll be giving 1 star, single star, double star, up to 5 star. If the rating is above 86 and above, then they'll be given a 5-star rating for 5 years from the award of the rating. So what are the criteria? Simply we'll just go through that one. Whether it is having accessibility to the basic service, like to reduce the use of private vehicles and promote walking, cycling. We just mentioned cycle track and public transport. The microclimatic impact, the intent of this criteria is to encourage plantation of trees and implement adequate measure on site to reduce the impact of urban heat island. That means surface temperature rising can be reduced by planting the trees. So what measures or what is followed in that particular site, that has to be seen. Criteria number 3, maintenance, green procurement, and waste management. The intent of the criteria is to ensure that good practices are followed in operation and maintenance of the building system, eco-friendly, whatever the material they are using, and biodegradable, that means durable one, long-lasting one, or used for housekeeping, energy-efficient appliances, etc. And criteria number 4, metering and monitoring. The intent of the criteria is to promote reliable metering of energy water consumption. So properly, it should be metered. Okay, how much energy, as far as electrical energy is concerned, and what the water consumption is concerned per month or something like that, it has to be recorded. Energy efficiency, criteria number 5. The intent is to enable the project to reduce their energy consumption by use of energy efficient strategies. It can involve implementing energy efficient lighting, efficient HVAC system, elevator systems, etc., as well as renewable energy production via solar panels. So we are using some solar panels, that can add added advantage. We are using some efficient HVAC system. What do you mean by efficient HVAC system? By means of building management systems, is it not? But whatever the coolness which is required, that only we will be having. So it is everything. We are having the automation techniques, efficient HVAC technique. Implementing energy efficient lighting. Again, it is automation again. Wherever the light is required, that only will be lighting, energy efficient lighting, etc. Criteria number 6, renewable energy utilization, is to promote the use of renewable energy technologies and energy generation on the site. Renewable energy technologies. Yeah, that's right. Construction materials. Again, it can be reused. It can be reused again. And I just told you some of the materials which can absorb the carbon also. So emission can be lesser over there. Water footprint. The criteria is to estimate the water consumption under different applications. And criteria number 8, reduction in cumulative water performance. The criteria is to promote water reuse and recycling to meet the non-potable water use requirement and to reduce the overall water demand from the local municipal water supply. Reuse and resupply again. Criteria number 9 is to ensure that the interior space of the meal meet thermal, visual, and acoustical comfort as compared to the benchmark. Yeah, by using the materials, whether you see, I just told you about the insulated medium and all, insulated panels and all. So acoustics, as far as the AC is concerned, as far as the thermal lighting is concerned. Then criteria number 10. The objective is to ensure good indoor air quality and quantity for all occupants inside the buildings by means of proper design of the windows, etc., etc. Then criteria number 11, and environmental awareness. The intent of the criteria is to make the project accessible for persons who are elderly and differently able. Yeah, that is also criteria for elderly people and differently able people. Okay, accessible for those people and to increase the environment awareness among the building users. And criteria number 12, the intent is to promote adoption and implementation of innovative strategies in improving sustainability of the project. I just told you, like building management systems and all. Some of the criteria. Okay, I just we'll just go through this particular case here, that is CIE Sorabji Godrej Building, Hyderabad. Okay. So we'll see here the site, as far as the design is concerned. Within the site, the building is located on relatively flat sections, such as the natural topography. They have not disturbed the topography, etc. It is left undisturbed. Lush vegetation surrounds the building form in order to reduce the pollution from outside entering the building premises. We have just seen. Okay. Then, besides taking measures to control topsoil erosion, the most important one, they are having proper vegetation so that it will control the erosion. The design was conceived to produce minimum disturbance upon the ecological environment of the site, limiting up to 40 feet from the building footprint. This has carried a significant role in the conservation of ecosystem by not hampering the existing flora and fauna. They have maintained that one so that topsoil erosion is prevented. As far as the material is concerned, waste material from industry, I just told you, like they have used actually aerated concrete blocks or something like that. Okay, they were recycled and used for the construction of materials. Then construction waste and leftovers were repurposed by dispatching them to other sites or recycled. Okay, they don't end up in landfills or something like that. It is recycled. Majority of the build form uses aerated concrete blocks. I just told you, for facades made up of fly ash, they have used that wastage material. They act as insulators. We know that aerated concrete is nothing but intrusion of air inside the concrete. So we'll be having the air pores. As such, air pores are a better insulating material. Other materials such as include glass, aluminum, ceramic tiles, and bagasse-based composite wood for office furniture. That's it. That is the engineered wood. Indoor air quality, how it is maintained. Building rating system give considerable credit to IAQ, indoor air quality, as it defines occupant comfort. Passive technologies are used to maintain thermal comfort by drawing in fresh air like wind towers. They were having a wind tower technique. What is a wind tower? Is to catch the cooler breeze that prevail at a higher level above the ground and to direct into the interior of the building. See, it is just observing, or it is just taking the cooler breeze, catch the cooler breeze above the ground, and it is directly into the interior of the buildings. That way, the IAQ is maintained. Supplementary strategies include reducing toxins by use of low VOC paints and all. They have not used that one. Okay. As far as water efficiency is concerned, specially designed sanitary fixtures like ultra low and low flush fixtures for WCs helps the building range. They have used that one. The generated water, gray and black, that be storm water or gray water, black water, is treated in the roof zone treatment system up to standards listed by CPCB, Central Pollution Control Board. The treated water is further used for watering the landscape area. Whatever the water that is coming, let it be a black or gray water, it is just reused. Again, this is something like a fenestration. They are having like this. You can see here they are having a curtain wall glazing system. The glazing act like an insulator also. Okay, natural light we can see here. That is possible. So that way, from the initial stage, extensive energy stimulation were embarked on to work out the orientation, building form, fenestration to minimize the heat ingress by allowing natural daylight. Although daylighting reduces the lighting energy demands, it brings in heat radiation, which is lowered. Again, we know that daylight enters, heat radiation can be there, which is lowered by using double glazed panels. They have used the glass panels, which is double glazed with argon gas filling. Okay, insulator. It's an insulator. BMS, building management system, are installed for real-time monitoring of energy consumption. Okay, how much it is required as far as the lighting is concerned, how much power is concerned. So BMS is installed. The green roof covers more than 50% of the roof area and serves a dual purpose by earth sheltering to reduce the heat loss and help maintain a steady indoor air temperature by means of having the green roof. Remaining area is covered by installing solar panels. Up to 20% reduction in the energy demand is possible. Okay, that way we can see here, this is that particular building where natural light, fenestrations, all those things are available. Critically regional. The concept of the structure derived from the Pachabutas, which dictate the life axis by balancing them. Whatever is drawn itself from the nature must be returned to that. So the building reduces footprint by giving back to nature as it borrows from it. That's what is rated as a platinum rated building. Coming to the sustainable construction practices, it is the adoption of materials, mainly the materials and products and construction that will require less use of natural resources. I was telling you about the cement, whether we can eliminate the cement. Yeah, research is going on. Now, a lot of geopolymer concretes are coming where we are using some wastage from the other industry and all. So it is possible. And steel again, yeah, steel, other metals, glass, prefabricated. Yeah, that is also important. And nowadays we are having a lot of prefabricated techniques, precast techniques and all, where we are making the buildings or the panels outside and bringing to the site. As far as the steel is concerned, it is just bolted, it is just riveted in the site. That means we know that the quality wise it is better. The wastage will be minimum. Yeah. We can reuse the forms and all as far as the prefabrication is concerned. And precasting, we know that as far as the precast concrete blocks or precast slab panels or something like that, we are using it. It is brought from outside and then placed in that particular site. So that can be an example for a sustainable construction practice. Prefabricated buildings are known for the material efficiency. Just now we told, these buildings do not produce waste since all the required material arrives at the finished state in the construction site, and in the factory it can be reused again. Precast concrete slabs are more sustainable because they take less energy to produce. Reusing of construction processes such as molds and forms is possible, thereby the reducing waste. Mainly the precast, we are going for precast blocks or something like that. Aerated block is a precast block. So we are reducing the energy which is required for the making of that particular material. Recycle components, low water cement ratio. Yeah, low water cement ratio as far as the precast is concerned. How much water is required as far as the concrete is concerned? Mainly in the construction sites and all, we might have seen they will be using a water cement ratio of 0.4, 0.5 and all. Whether that much is required? No, as far as the research is concerned, 0.3 water cement ratio may be sufficient for hydration. If at all we use extra, that will be available in the concrete as pores, and that pores will allow the water and air to pass through. That leads to, again, you see corrosion of that particular steel or something like that. So low water cement ratio, that is important as far as the precast of building is concerned. Good insulation, thermal property, energy efficiency, durability, better quality. That's what recyclability help the precast products minimize the carbon and water footprint while delivering excellent living and working conditions. Steel, yeah, it's a good one because prefabricated buildings, it's an excellent reusable material. There's no waste as far as the steel is concerned, is it not? Even the scrap steel, we are using that. It is having the highest strength to weight ratio. We can compare it with the concrete or something like that. The weight of the steel is nearly 7850 kg per cubic meter. The weight of the concrete, we know it is 2500 kg per cubic meter. The tensile strength of the steel is nearly 500 MPa, it is that, but tensile strength of the concrete, we know split tensile strength, it is only, we can tell 10% of the compressive strength, it will come to about, we say 5 MPa or something like that. So the steel is having 3 times weight of the concrete, but as far as the tensile strength is concerned, it is 100 times more than the concrete itself. That's what is mentioned there, highest strength to weight ratio. So steel fabricated buildings. When connected by fasteners, the steel frame is stronger than the traditional system, and this provides savings in the foundation. Yeah, correct. There is no need of that much load that is coming to the foundation. Yeah, if we are going for the normal concrete building and all, we know the dead weight which is coming up, but here it is just connected by fasteners. Then the speed, it takes lesser time for connections and all. The time saving is nearly 40%. Minimum disruption in the construction site. In city locations and all, it can be useful. Steel construction minimize the noise and dust. That is there as far as the concrete construction is concerned. So steel, better buildability is there. We are using the framing materials. And this reduces the amount of site work because only connection fastenings we are doing, and it is also environmentally friendly. Steel offers a clean, efficient, and rapid construction method which reduces the impact of the building industries on the environment. All steel products are 100% recyclable, and that is what is considered to be a sustainable construction material. Okay. One more thing as far as the construction material is concerned, one of the greenest building in the world is the Edge. Located in Amsterdam, it uses natural LED lighting. I told you, proper automation here, resulting in 70% less electricity usage. Oriented along the sun's path and using solar panels covering much of its roof and south-facing walls, the building produces more energy than it consumes, providing, that's whatever we take it from the nature, that has to be brought back. So this particular building, it is having a south-facing wall. The building produces more energy than it consumes, providing power for the entire property by using the solar panels. Deep wells pump warm water into an aquifer. You see here that can be stored as thermal energy, pumping it back in the winter to provide the radiant heating while air ventilated through the roof keeps it cool in summer. See here, natural. Whatever from the wells, the water is pumped into an aquifer, warm water. It stores that particular thermal energy and then pumping it back in the winter to provide radiant heating while air ventilated through the roof keep it cool in summer. Additionally, the building collects rainwater in big barrels for toilets and drip irrigation in the garden. That includes the beehives and the habitat for the bats and all. The edge, that is a particular building, goes beyond green. It integrates smart technology. Yeah, what is that? A digital lighting control system with sensors monitoring occupancy, temperature, and movement allow for better management of energy consumption. Digital lighting control, sensor monitoring occupancy wherever it is required. That much light will be coming. So when fewer employees are present, whole part of the building can go on standby for energy conservation by means of digital lighting system. With no permanent desk, employees choose workspaces that best suit their needs wherever it's required in that particular building. Smartphone apps helps employees find parking spots, available desks or colleagues, while also noting each person's preferred lighting and temperature to adjust the environment accordingly. They have used that particular automated technology, how much it is preferred for each person. Based upon that one, they can use that one. So what are some of the smart designing methods? We have seen the green concepts and also green building concepts, and also we have seen the sustainable construction practices. And what can be some of the smart designing concepts as far as the latest technologies are concerned? We are using building information modeling. It can help estimate requirement of the materials at every stage, how much energy, how much material is required for each stage, and this reduces the chance of over-ordering of materials. That is important as far as the prefabrication, precast, as far as the construction in the site is concerned. Over-ordering is again waste. The material which then end up becoming waste. Designing insulation for the entire project can help prevent energy loss. I told you just now, by means of having the insulation panels. This can be done by using materials with good insulation properties, using insulating materials over standard elements. Smart placement of windows throughout the structure can further help in avoiding the energy loss wherever we require the light. So south-facing panels or something like that, wherever it is there. So it will, the air will be going inside that way. We can have smart placement of windows. The design should also integrate systems such as rainwater harvesting, phase management systems, etc., etc. Adding trees, mainly plants, garden to the project. We know that that is what CIA they have done over here. They have plant the gardens to the project, which will improve the air quality in and around the project. That was IAQ. We mentioned that one. Indoor air quality. Design should also account for the reuse of grey water, storm water for domestic uses, which in turn reduce the demand of water. So some of the designing methods and considerations, smart designing methods, I was just telling about the building information systems, building management systems and BIM, etc., and all, how much material is required, how the building looks like. All those things can be done with the help of all these smart designing methods and considerations and all. Okay, use of recycled or sustainable materials. Use of prefabricated element. Just we mentioned what can be the advantage when we go for the sustainable construction aspect of a prefabricated building or a precast, concepts or something like that. Use of prefabricated element during the construction process would also benefit, since generation of waste will be minimum here in the precast industry. As well as the prefabrication industry, the waste can be recycled, the forms can be reused once again, so the wastage will be minimum. That way we can reduce the cost also. Use of appropriate substitute for naturally occurring construction materials. Nowadays, you see, I just told you about the cementitious material. In place of that one, we can go for the siliceous materials like admixtures and all. So naturally occurring construction materials can get reduced. Materials like masonry blocks made of construction waste would also have lesser impact on environment. We mentioned in the introductory stage itself that brick is a material which will consume maximum energy. It will emit maximum carbon also. So how to replace the bricks with some other materials like AAC blocks, like stabilized compressed earth blocks or something like that. That way the construction waste can be minimized, the energy consumption can get minimized. And even for the aggregates and all, as far as the construction material is concerned, we can use some aggregate like lightweight materials, is it not? Which may not be granite or basalt or trap, etc., and all, but lightweight materials which will be having the pores inside. The only problem is that strength is a problem. But again, when we use admixtures or something like that, then the strength, we will be able to increase the strength of those lightweight aggregates also. That way we can use those lightweight materials for the construction of buildings and all. So it will be having a proper insulation also. That can be an advantage. Only the strength concept, that is the most important concept as far as the lightweight concrete buildings are concerned, and the strength can get increased by using some admixtures like chemical and mineral admixtures we can use, so that we can get a minimum compressive strength of nearly 20 MPa, which is sufficiently required as far as the structural components are concerned. And you can see the last point here, replacing the masonry blocks. That means masonry, bricks with some other material. Okay. so that we can, those particular blocks can consume less energy as far as it can emit less carbon or something like that. In that particular instant, we have done just research over here by using some stabilized compressed earth block. You can see here, it is just, nowadays, we are just casting it everywhere. In Karnataka, it is happening there. They are having this particular blocks, which is just soil. It is just soil. It is compressed with the help of some soil making press or something like that, block making press. And this particular mix design, it requires soil as far as little lime or something like that. Lime, fly ash can be used. It can be mixed, and then it can with a specific water content, and then it can be compressed with the help of the press or something. It can be taken out, and it is just moist cured or something like that. Air cured. We used to see it is air cured. It is completely covered with the polythene cover or something like that. It is air cured, and it is having a better strength, comparatively equal strength as to that of the brick and all. So this particular block can be used. And as far as the energy and emission is concerned, why we are using this one? We can use, why? Because we can use the admixtures again. I told you we are using the admixtures. And this particular block, we have made it with ricer's cash. Because we know that about 20 millions of ricer's cash is produced annually worldwide. We have to use that one. It is not ricer's, it is ricer's cash. We have to use that. Highly reactive ricer's cash is an excellent pozzolanic material. It's a siliceous material. So we have to use little bit cementitious material also, like lime or something like that. It's an excellent pozzolanic material. And stabilized compressed earth blocks using ricer's cash are use locally available soil with little lime. So whatever the soil which is available on the surface, that we are collecting, not the clayey soil, which is required for the agriculture, that we are not taking in. So whatever which is available on the surface, it will be having a silt content, it will be having the sand content, it will be having the clay content, and then we are mixing with the ricer's cash and lime to produce this particular ricer's cash block or stabilized compressed earth block. A composite of earth stabilized with ricer's cash could produce an eco-friendly, sustainable wall material. Why it is eco-friendly? Because there is no, burning or something like that. So emission is not at all there. We are not at all using energy. Manually, it can be compressed. The use of cement replacement material with lower environmental burden offers opportunities for significant reduction in energy use and carbon dioxide emission. And this will encourage the construction agencies and entrepreneurs for commercial production of ricer's cash stabilized soil blocks. In many of the projects in Bangalore, they are using this type of technology. They are replacing even AC blocks with the stabilized soil blocks or something like that. So these are the press we have used for compressing this particular ricer's compressed blocks. Mixed design, I just told you, it is soil, lime, ricer's cash. These three are mixed together. And total energy requirement, as far as lime is concerned, you'll be having little bit energy. Yeah, 3.15 megajoules per block is required. Ricer's cash, it is nil. We are just burning it and burning under controlled temperature so that the emission will be minimum. So total energy requirement, as far as one block is concerned, is 3.16 megajoule. And a block of brick size equivalent, because it's of a bigger size. As far as the brick size equivalent, the energy consumption is nearly 1.12 megajoules. And as far as a brick is concerned, the energy consumption is nearly 4.25 megajoules. We can see it will consume only 25% energy as far as the brick is concerned. So this can be a better and eco-friendly material. As far as the carbon emission is concerned, again, we are using lime. It will be having little bit carbon emission, 0.51 kg per block is required. Ricer's cash, we are burning it. So 0.08 kg of carbon dioxide will be there. So total carbon emission for a brick size equivalent is only 0.21 kg. But here for the brick, we have seen earlier, it is 0.38 kg per brick. And here it is 0.21 kg. That means nearly 50 to 60% only we are using that one. So that way, emission is also less. So it is an eco-friendly material. As far as strength is concerned, I just told you, it is having a strength comparable to that of the brick, nearly 5.11 MPa. That is the compressive strength is nearly dry and wet. It is given here 3.53 MPa. The brick is nearly 4.95 MPa. Density is good. Water absorption is very less as far as this block is concerned because it is having more density. As far as the cost is concerned, it is coming to nearly 4.56 blocks, 4.56 rupees. For a brick size equivalent, for normal brick and all, as far as the market rate, it is nearly 6 to 7 rupees and all. So it is 60 to 70% as far as the brick is concerned. And this is considered to be a sustainable construction material. And this project, we have done it over here to see that, or to show that it consumes less energy, as also it will emit less carbon, and also the cost is comparatively lesser than the burnt clay brick. Finally, coming to the conclusion, what is the need of sustainable alternatives? Just now we mentioned in this nearly 40 to 50 minutes lecture. Steel, cement, glass, aluminum, plastics, bricks are energy-intensive materials commonly used for building construction. You replace that. Steel, again, yeah, it can be recycled. Cement, we have to replace with some other material. Glass, glazings we have to use. Generally, these materials are transported over to long distances. Extensive use of these materials can drain the energy resource and adversely affect the environment. On the other hand, it is difficult to meet the ever-growing demand for buildings by adopting only efficient traditional materials. Yeah, it is not possible for us to use only mud, cast, timber, etc. So we have to use some other materials which can replace these energy-consuming materials or something like that. It will be having the better strength when compared to the other, conventional construction materials, because it is not at all possible, or it is not at all easy to meet the energy of traditional, to meet the demands with the help of only this traditional construction materials like mud, thatch, etc. And also, we have to replace the normal construction material with some other by using some techniques which can be reused, and also which will be having a better strength, consumes less energy, and emit less carbon. Hence, there is a need for optimal utilization of available energy resources and raw materials that is carbon negative. I just told you in the introduction, we are having some materials that is called as the waste from the iron and steel industry, that is called the iron powder. With the help of admixtures, it is called as ferroc. Research is going over there, which will observe carbon from the atmosphere also. So it is considered as carbon negative construction material to produce simple, energy efficient, environmentally friendly, and sustainable building alternatives and techniques to satisfy the increasing demand for the buildings. And this is possible by decentralized production, that means locally available, and maximum use of local skills, utilization of industrial and mine waste. We mentioned that for the production of building materials, minimize transportation, locally available materials we have to use so that we can minimize the transportation, and maximize the use of local materials and resources, and recycling the building waste. So these are all the things which are required as far as the green building concept is concerned, as far as the sustainable construction practices are concerned. We have to use the locally available material, we have to use the local skills, we have to go for the mine waste and the industry waste, we have to minimize the transportation, and we have to maximize the use of local materials and resources, and we have to recycle the building waste or something like that. And that way, it is possible to adopt the green building concept, and also it is possible to adopt the sustainable construction practices. Thank you.
Thank you, sir.
Yeah.
Any questions?
Hello, am I audible?
Yeah, audible. Please.
Good morning, sir. Myself, Dr. Kavita. I just want to get some expert opinion from you. I've been working on the life cycle assessment of solar panels.
Okay.
So in that case, as a civil engineer, it will whether it will be worth trying the inclusion of solar panels that is obsolete as in powdered form as aggregates or fine aggregates into the concrete, so that we can utilize the obsolete solar panels in a better way. Is it sustainable? I would like to know the possibility of doing such a work.
Yeah, madam. Again, I told you, the research is going on in that one also. Nowadays, we are having the absolute solar panels only, but research still is going on to have some artificial method of making that one by using some other material like sustainable construction material and all to make this solar panel. So still it is going on in the research stage only, madam. But I think we may be able to use that one. We may be able to use that one, madam.
Okay, sir. Thank you.
Yeah. Thank you.
Thank you, ma'am. Any other questions?
Hello. Hi, sir. I'm Nandana from Expo Civil. My question is, how do you introduce and apply these green methods in remote areas with weak economies and basic infrastructure?
In remote areas, sustainable construction practices, you're asking, am I right?
Yes, sir.
Yeah, it's possible. It's possible. You see, I just told you, we have to go for some locally available materials. You see, many construction materials or something like that, we are bringing it from outside, like cement, whatever it is. So locally available construction material, if we use, then those material can be sustainable one. I told you, even the soil, locally available soil is a pozzolanic material. So just it's a siliceous material. When we mix with some cementitious material, we can make that one. So locally available materials, if we use, it can lead to sustainable construction aspect as far as the material is concerned. Then as far as the design is concerned, even the remote stage and all, nowadays, as such, there is no remote stage as such. Everywhere we are having the concept. So the design of that particular structure also must be based on some green building concept. So windows, the orientation of the windows, natural lighting, etc., etc. So it is possible.
Sir, we have one more doubt.
Yeah.
Sir, whether the practice of Vastu Shastra enables sustainable construction practices? Is it advantageous to use Vastu Shastra?
Madam, that is not the scope of my lecture. Okay, it may be, madam. Vastu Shastra is a different science itself. No? Maybe they are told something sustainability in that also. They are told that also. Okay.
Okay, sir. Thank you.
Yeah.
Yeah, any other doubts? A very warm good morning. It's indeed esteem and privilege to deliver a word of gratitude at this moment. First of all, let me thank God Almighty for making this a very resonating occasion. We are extremely grateful to the speaker of the session, Dr. R. Sathish Kumar, Dean, School of Construction and Technology, NICMAR, Hyderabad, for sparing his valuable time and information regarding the concepts of green building and sustainable construction practice that can be implemented. As sprouting civil engineers, this will surely help us think in an innovative path. A modest way of thank you to Dr. Gigi Anthony, Head of Department Civil Engineering, who have been a constant source of inspiration and support. With utmost love, I thank our faculty and students for their endless effort for making this a great success. Thank you all.
Yeah, thank you. Thank you
Thank
all
you, sir.
for giving me the opportunity also. Thank you, students.